Built around 1333, stretching over 200 meters and made entirely of wood, Chapelbridge has stood for nearly 700 years across the Reeves River. But how could a wooden bridge remain strong against water, moisture, rot, and the passage of time for so long? And how were medieval craftsmen able to install rows of wooden piers in the middle of the river without any machinery? Even more astonishing, in 1993, a fire destroyed nearly 2/3 of the bridge. Yet the structure was rebuilt almost exactly as it once was. The secret lies in the very way it was constructed. It was only a small river, yet it once split an entire city in two. Not a vast sea, not dangerous terrain, just the quiet Reuss River flowing through Lucerne. But for many years to travel from one bank to the other, residents had to rely entirely on boats. Every crossing was not only slow, but completely dependent on the weather and the current. Transportation became costly, trade was disrupted, and the old town itself seemed divided right through its own heart. A river that appeared gentle and harmless had become an invisible barrier holding back the city's growth. Then, around 1333, a bold decision was made to build a wooden bridge, more than 200 meters long across the entire river, a project that at the time almost no one could be certain would succeed. The greatest challenge was not the length, but the location. Building over water has always been difficult, especially without modern machinery. There was no stable ground, no solid support point, only constantly moving water below. Yet medieval builders found a way to begin with the foundations. Massive timber logs were driven deep into the riverbed to form foundation piles. Not just a few isolated piles, but an entire system arranged in a precise network. These piles were grouped into clusters and tightly connected to distribute loads, creating a foundation strong enough to support the entire structure above. On top of that foundation, the bridge piers gradually rose. There was no concrete, no steel, only timber and stone. Timber formed the outer frame while stone was tightly packed inside to increase weight and stability. This combination allowed the piers to resist the current and withstand erosion over time. Once the piers were completed, the span structure began to take shape. Large wooden beams were placed horizontally between the supports forming the main load-bearing frame. Then, diagonal timber members were added, creating a triangular truss system, a simple but highly effective structural principle that distributes forces and keeps the entire bridge stable. This truss system is precisely why the bridge has survived for centuries without major deformation. However, the most remarkable feature lies in the roof. Instead of leaving the structure fully exposed, the builders created a covered roof running along the entire length of the bridge. This was not decorative, it was a decisive engineering solution. In a damp environment, wood can decay rapidly if directly exposed to rain and snow. The roof acts as a protective shell, keeping the internal structure dry and dramatically extending the bridge's lifespan to hundreds of years. This is the true secret behind how a wooden bridge could survive for nearly 700 years. Inside the bridge, more than 100 triangular paintings are mounted beneath the roof, many of them created in the 17th century. These artworks are not only visually striking but also preserve the history and culture of Lucerne across generations. The bridge, therefore, became more than infrastructure. It became part of the city's collective memory. When completed, the bridge measured about 205 meters in its modern form, directly linking both banks and completely transforming the way people moved through the city. No more waiting for ferries, no more physical separation trade. It became continuous and reliable, and Lucerne began to grow far more rapidly. But the story of Chapel Bridge is not only about construction. In 1993, a devastating fire broke out and destroyed nearly 2/3 of the bridge in a single night. The flames spread rapidly through the dry wooden structure, destroying many of the historic paintings and collapsing major sections of the bridge. For a monument that had survived centuries, it was a tremendous shock. Yet astonishingly, the bridge was reconstructed almost exactly as before in just 8 months, preserving its original form, roofline, and structural identity. This proved that its true value was not only in the material itself, but in the brilliance of the design principles behind it. Today, Chapel Bridge is not simply a 200-meter wooden crossing over the Reuss River. It is one of Switzerland's most iconic cultural symbols, attracting millions of visitors every year. A timber structure first built in the 14th century has endured for nearly 700 years, surviving both time and fire. Not because of modern technology, but because its builders understood timeless structural principles from the very beginning. And perhaps that is the most thought-provoking part. While we now possess more advanced technology than ever before, do we truly understand how to apply sustainable solutions as wisely as people did hundreds of years ago? Or are we still searching for complicated answers to problems that were solved long ago?